This is Triangle Congruence Day 2, so 6D Day 2. All right, first things first, couple of refreshers. Symbols to know, angle. Okay, so let's say we have this angle here. How do we name it? Angle, make sure you include that. BAC, where A is the vertex, so it has to go in the middle. You could name this angle CAB if you wanted. That'd be fine. Okay, triangle ABC. Triangles have to be named with 3 points. So basically figures, like a triangle, a rectangle, whatever, have to be named by however many letters they have vertices. So since a triangle has 3 vertices, A, B, and C, it has to have 3 letters. If it was a square, A, B, C, D, then it would have to have 4 letters because a square has 4 vertices. You can name a triangle any way you want. If you're naming just the triangle. However, if you're naming 2 congruent triangles, you have to make sure that their vertices correspond to the congruent parts. And again, make sure you have the triangle symbol in front. Parallel lines. Okay, these arrows here mean that these 2 lines are parallel. So we say line MN is parallel to line CD. And notice we have the line symbol above it. Okay, make sure you include that, and then this parallel symbol. Congruent. You should know by now that this is a congruent symbol, so that means that they have the same measure. So PR is congruent to KL, PQ is congruent to LJ, and so on. Now this is how you would name your angles with 3 letters. Remember, angles can be named with 1 letter if and only if that vertex is a vertex for only that angle. So RQP or PQR, I could actually say is angle Q, because Q is only a vertex for that angle, and that would be congruent to angle J. Okay, you would not be able to do that if there was this other line here, and let's say this was T. Then we couldn't say angle Q, because now we have 3 angle Qs. But that's not the case. That's just a friendly reminder. And then perpendicular lines are lines that when they intersect form right angles. So we would say that AB, segment AB is perpendicular to segment MN, and on a diagram this square would mean that that's a 90-degree angle. So 90-degree angle like that means that those lines are perpendicular, and if you're given this information you can assume this then. And again, the perpendicular symbol is that upside down T. Alright, so now what do you think a midpoint means? Look at the pictures, I think you can probably figure it out, but a midpoint is a point or segment or ray or line that divides a segment into 2 congruent segments and bisects the segment. The bisection point is called the midpoint of the segment, so that's this right here. So if we said that ray CH bisects segment AB, that would mean that AC and CB were congruent. Okay? Reflexive property is a property of equality that says that anything is equal to itself. Now, why is that useful? So let's say we were given that AD was congruent to AB and DC was congruent to CB. All right, how would that help us? Well, if we needed to prove that triangle ACD and triangle ACB were congruent. Well, the reflexive property allows us to say that AC is congruent to itself, because essentially we have 2 triangles here, ACD and triangle ACB. So that would be congruent to that. This would be congruent to this. And then because of the reflexive property, we could now prove those triangles congruent by side, side, side. And again, it's not something that you can just assume, and it's something that has to be stated because we are getting into proofs now. Now, proofs, basically, it's helpful to label your diagram that you have along with the proof using the given information. So you're going to be given some information. Label the diagram with how that helps you. And then you write the given information in the proof. That's the first thing you write. Okay, and then you use the statement column, or the statement that you need to prove. So basically, statements are things like angle A is congruent to angle C, segment BD is congruent to segment whatever. And then the reasons are why you can say that. So the information that goes here is like the triangle theorems, definitions, and postulates. So let's take a look at one. So we have these options, and we need to complete the proof. All right, so we are given that JK is congruent to NK, which is labeled on the diagram already, and that A is the midpoint of JN. Well, what does A being the midpoint of JN tells us? It tells us that AJ and AN are congruent. Okay? And now it helps, before you even start, to look at what you're trying to prove. You're trying to prove that triangle JAK is congruent to triangle NAK. So start off looking at that and saying, well, what options do I have? How am I going to use the given information to prove those triangles congruent? Well, there's two theorems that we have that involve two sides. So there's side, 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 and there's side, angle, side. So it's got to be one of those. It can't be angle, side, angle, because we have an extra side that we wouldn't be using. And couldn't be hypotenuse leg because we don't have anything about any right triangles here. So it's going to have to be one of these. So you go down to your statements and say, okay, well, first thing I do is write down my givens. So I would do JK is congruent to NK, which I have right up here because that's a given. And then I would say that A is the midpoint of JN because that's a given. All right, now you have a few options. You see that the reflexive property is in there, so you know that you're going to have to do that because that's about the only part of this diagram that you would be able to use the reflexive property on. Little side note about the reflexive property, it can be used on angles or segments. All right, next, your proof. This is always going to be the first statement. This is always going to be the last statement. So this proof you can fill in just at the bottom right away. And if you notice, there's only one way that's listed to prove the triangles. So we know we're proving by side, side, side. So we can go ahead and put that in there. All right, so now we've just got these two things left, and I've got the reflexive property. So which one of these do you think is a reflexive property? Pretty obvious that it's AK equals, or is congruent to AK. So we would put that in there, which leaves a midpoint divides a segment into two congruent segments. So notice I said that JA is congruent to NA, and that's because this led us to that. And again, we kind of state that here, midpoint divides a segment into two congruent segments. All right, so go ahead and try this one on your own. This is a fairly easy one, a three-step proof. So we'd have AC is congruent to EC and BC is congruent to DC. Next, what are we trying to prove? We're trying to prove the triangle ABC is congruent to triangle EDC, so we state that last. How do we prove triangles congruent? Well, there's only one thing that's listed, side, angle, side. So we put that there. And then vertical angles are congruent, something we went over. So what are our vertical angles? DCE, BCA, or however you want to label them. And that would go in there. Pretty easy. Okay, so you try this one on your own. I would like you to pause the video and see if you can fill this in on your own. Don't just copy down the notes here. Really take a minute and just see if you can do it. All right, so if you did it correctly, you should end up with this. Again, start with your given. Those are listed there. Okay, your proof right there. We can cross that off because we would put it down here, which would only leave KM is congruent to KM. All right, last one, a four-step one. If you think you could do it, actually, if you really wanted to test yourself, you would cover up the options and see if you could fill it in without anything. But as it is, again, we're only given one given this time, that X is the midpoint of segment AG and of segment NR. So we would write that in after we put our markings on our diagram that we know. Vertical angles theorem, well, there's only a pair of vertical angles in there, and that's ANX. Well, no, it shouldn't be ANX, it should be AXN. And it should be GXR. Typo. Oh, those are triangles, sorry. So that's right. So triangle ANX is congruent to triangle GRX. And again, by side angle side, X is a midpoint. That's obviously a reason. So vertical angles, that's this right here. AXN, GXR, those two are congruent because they're vertical angles. So anytime you see vertical angles theorem, look for lines that intersect and form angles. Make sure your proof always goes in your last spot. Make sure your givens always go in your first spot. And then just kind of fill in the rest. You know, see what you can find out. Like it says X is a midpoint of two separate segments, which means we have two pairs of segments that are congruent to each other. Now, they're not all congruent to each other. These two are congruent and these two are congruent. But it doesn't mean that they're congruent to each other. So be careful of that. All right, that's it. Only a couple more targets in this unit. So hopefully you're keeping up and understanding. And if you have any questions on this, please let me know.